Hello, algebra students. Mr. Lawrence here, and pardon me, a little bit hoarse still. Yeah, still not driving the vehicle, riding the horse. Anyway, we're going to start something new. It's called solving systems. It says stems. It should say systems. Sorry about that. Systems using substitution. Now, I don't know if you remember, we solved systems of linear equations by graphing a little while ago. And the problem with it is that sometimes we couldn't tell exactly where the two graphs cross. We kind of have to guess. Well, with the methods we're going to learn over the next couple of days, pardon me, you won't have to guess anymore. So, solving systems by substitution. Now, before we actually get down to this, it's actually pretty easy. If you ask the honors kids, they've already done it. It's pretty simple. You have to understand what it means to say two things are equal. It means they have the same value. It also means they can take the place of each other. For example, 2 plus 3 equals, oh, that's not a 3, Mr. Lawrence. 2 plus 3 equals 5. It means that 2 plus 3 and 5 are interchangeable. Watch, I'll prove it. 6 times 5, of course, is 30, right? Well, what is 6 times 2 plus 3? Now, if you want to do it by distributing, you could say, well, that's 12. And you could say that's 18. And 12 and 18 is 30. Or if you follow the order of operations, you do 2 plus 3 and then you have 6 times 5. But you see, the important thing is to realize that if something is equal to something else, it can be substituted in its place. I said 2 plus 3 was the same as 5. I substituted 2 plus 3 in for 5. Okay? So check out these two equations over here. We've got y equals 2x minus 4. We also have y equals negative 2x plus 4. That means that this and this are equal to each other. Sure they are. If this is equal to y and y is equal to that, remember the whole transitive property, a equals b equals c, then a must equal c. A equals b, pardon me, b is the same as c, then a and c must be equal to each other. Yes. So I can write these two equations as one brand new equation. I can take 2x minus 4 and make it equal to negative 2x plus 4. And now I have one equation with one variable. If I get all my variables on one side and all my non-variables on the other, I can solve for the variable. So I'm going to add 2x to each side. Okay, and I'm going to get 4x minus 4 equals 4. And then I'm going to add 4 to each side, right? You following me? And I'm going to get 4x equals 8. Divide by 4. And I'll get x equals 2. I know the x coordinate of where these two lines will cross. They're going to cross at 2 something, the point 2 something. All right? Now, to figure out the y coordinate, I'm going to take this 2 and substitute it into either equation, either into the first one or the second one, your choice. I think I'll use the first one. I think it's a little bit friendlier. I'm going to go y equals 2 from there, and then the x is also 2, and then minus 4. Oops, I don't need that parenthesis there. Sorry about that. Let me get rid of him. All right. So y is going to equal 4 minus 4, which is 0. So these must cross at the point 2, 0. Now we're not always going to graph to prove that we're right or wrong, but I will do it in this first case just to make sure you're understanding. So my first equation was y equals 2x minus 4, just using Desmos.com. And then my second equation was y equals negative 2x plus 4. Oh, that's not in the right place, sorry. The second equation, y equals negative 2x plus 4. And look at that, look where they're crossing. Right there at 2, 0, just like I said. All right, you can use Desmos to check your work, by the way, if you like. We're not going to be doing that on paper a lot. Sometimes the equations look like this, okay? It says y equals x plus 4 and 2x plus 6y equals 12. Now, this is called substitution. I know that y and x plus 4 are the same number. Therefore, I can take this, the x plus 4, and put it in for y in the second equation. What that's going to do is it's going to give me one equation with one variable. So I'll have 2x plus 6. Now the 6 and y are being multiplied, so I have to go 6 times the quantity of x plus 4. That's going to equal 12. 2x plus 6x plus 24. How did I get 24? I distributed, right? Remember the distributive property? That equals 12. Now my x's are on the same side, so I'm just going to combine like terms right here. 8x plus 24 equals 12. I'm going to subtract 24 from each side. 8x is going to equal negative 12. X is going to equal negative 3. No, silly Mr. Lawrence. X doesn't equal negative 3. X is going to equal negative 12/8, which will simplify to negative 3/2, or negative 1/2. That's the x coordinate, negative 1/2. Now you might be starting to think you always find the x coordinate first. No, you don't. Excuse me. You find the one that's easier first, and I'll show you that in a minute. Remember, I've got the x coordinate. Now I have to plug it back into one of the original equations. I think this would be the easier one to use because y is already alone. I'm going to go y equals negative 1/2. Put that in for x plus 4. Well, negative 1/2 and a positive 4, I think will be a positive 2/2. And there you go. X is going to equal negative 1/2. Y is going to equal positive 2/2. That's where these two lines will intersect. Okay. Now sometimes they don't look so easy. Sometimes they look like this. We can't do any substituting right now because we don't have any variables alone. My advice to you is to look through the variables. There's 4 variables you have to consider. There's x in the first equation. There's y in the first equation. There's x in the second equation. And there's y in the second equation. Which variable would be the easiest to get alone, to solve for? It sure looks to me like solving for x in the second equation would be the easiest thing to do. So I'm going to take this second equation, x plus 10y equals 40, and I'm going to subtract 10y, and x is going to equal 40 minus 10y. Can't put them together because they're not like terms. All right, so I'm going to take this, and this is very important. I have to substitute it into the other equation. Can't do it in the same equation, not the one I solved for. Have to put it in the other. So I'm going to have 3x, nope, not 3x, sorry, 3 times the quantity of 40 minus 10y. Minus 5y equals 15. So all I did was rewrite the first equation. Instead of writing x, I wrote what x was equal to. How did I get what x was equal to? In the second equation, I got x alone. Why did I choose to get x alone in the second equation? Because it was the least amount of work. Okay, gave me the prettiest numbers with the least amount of work. So now I'll distribute, and I'm going to get a 120 minus 30y minus 5y equals 15. Like terms, because they're on the same side of the equal sign, 120 minus 35y equals 15. I'm going to subtract 120 from both sides. Get a negative 35y equal to negative 105. Divide both sides by negative 35. And y is going to equal 3. Yeah, 105 divided by 35 is 3. Okay, so now I know the y coordinate. I know the answer is going to be something 3. I'm going to go up to one of the original equations. Either this one, or, sorry about that, still nursing the cold. I hope I didn't blow your eardrums out. I couldn't warn you. All right, or I could even use this one because this x plus 10y equals 40 and this x equals 40 minus 10y are the same equation. So I'm going to choose this one here because it's going to be easier to do. So I'm going to do x equals 40 minus 10. What was y? It was 3. So x equals 40 minus 30, and x equals 10. And then there you go. They cross at 10, 3. Now take a look at number 4 here. Number 4, you have to decide, just like in the last one, are you going to solve for x in the first, y in the first, x in the second, or y in the second? Now, you can't make a wrong choice, although some choices will be easier than others. I'm going to recommend that you look at the coefficients and the constant. Solve only for a variable whose coefficient will divide evenly into the other two numbers. For example, the coefficient on x is 2, right? Does 2 go in evenly to 4 and to 6? It does, so that's a good choice. Does 4 go evenly to 2? No, it makes a half, it makes a fraction. Does 4 go in evenly to 6? No. I would not solve for y in this equation. The second equation, 3x minus 6y equals negative 6. Does 3 go in evenly to 6 and 6? Yeah, negative 6 and negative 6? Yes, it does. Does negative 6 go into negative 6? It does, but it doesn't go in evenly to 3. So I'm either going to solve for x in the first or x in the second in this particular case. In another problem, I might be solving for y in the second. It all depends. So I will go ahead and solve for x in the first. And so I have 2x plus 4y equals 6. First step would be to subtract 4y from both sides. When I do that, I'm going to get 2x equals 6 minus 4y. They're not like terms, so I won't put them together. And then I divide by 2. Now remember, you have to divide by 2 in all 3 places. This should be familiar. Oops, that's a positive 2 there, sorry. And so I'm going to get x equal to 3 minus 2y. Now I go to the second equation. And instead of writing x, I write this as a quantity. So I've got a 3, and then I have an x, so I have to write 3 minus 2y. And then I have a negative 6y. That's to equal negative 6. I'm going to distribute and get 9 minus 6y. Minus 6y equals negative 6. Combining like terms will get me 9 minus 12y equals negative 6. Subtract 9 from both sides. Negative 12y is going to equal negative 15. Divide by negative 12. Y is going to equal 5/4. I think that's right. Wait, I have a silly mistake, don't I? No. Divide by 5, divide by 3, divide by 3. Yeah, 5/4. Or 1 1/4. Okay. I'm not going to round that. I'm going to leave it as 1 1/4. If I want to leave it as 5/4, I can. Now, I've got to use one of those original equations or some form of one of those original equations. So I could use this original equation, I could use that one, or I could use this one because it's a form of that first equation there. So I'm going to use this one here because x is already alone. So when I do that, I'm going to get x equal to 3 minus 2 times 1 1/4. Well, 3 minus 1 1/4 and 1 1/4 would be 250. This would be 1/2 or 0 5/10, right? So the place where these two lines cross is 0 5/10, 1 1/4. And if you do that on Desmos.com, you type those two equations in, you'll find they do cross there. I feel like I have a mistake there. You know what? Let's go ahead and do it while I got you. And maybe I'll see what my mistake is. Well, now, what are the two equations? 2x plus 4y equals 6, and 3x minus 6y equals negative 6. All right. So let's go with 2x plus 4y equals 6, I think I said. And then, I don't remember that one. What is it? 3x minus 6y equals negative 6. So 3x minus 6y equals negative 6. And let's see, where are they crossing? Oh, look at that. I was right. I was okay. I was at 1/2, 1 1/4. All right, now on solving by a system, it would be really tough to know. The 1/2 you might be able to get, but the 1 1/4, how would you know it was 1.25? How would you know it wasn't 1.21 or 1.27 or 1.3? It would be difficult to tell on the paper that we graph on. All right, so that's it for the video. Hopefully you'll watch this more than once. When you come in Monday, we'll be getting some practice with this. Mr. Lawrence signing off. Have a good night, everybody.